Geometry 4.3 Congruence Postulates. We're going to prove triangles congruent using the definition of congruent triangles. We'll show that 6 pairs of corresponding angles and corresponding sides are congruent. We're going to do this using constructions as our basis. Our short vocabulary list has an included angle and an included side. We'll be doing 2 postulates. Postulate 4.3.1, which we call the SAS postulate, side angle side, and 4.3.2, which is the ASA postulate, angle side angle. This construction that we're going to begin, if you need to review copying angles, go to section 1.8 and review that procedure. You will be responsible for being able to construct congruent triangles from this point on. You begin by copying angle A from your original drawing. Then what you do is copy AC, the side AC, and the side AB from the original drawing, and you place it on your new construction. You label the intersections as you're asked to label them. In this case, angle A was copied to angle X, and AC becomes XZ, and AB becomes XY. Then we draw a line YZ, from the intersection of Z to Y to complete our triangle. We've constructed 3 congruent sides of 2 triangles. We copied angle A congruent to angle Z. Measuring would show that XY is congruent to CB of the original triangle, and that X was congruent to C and Y was congruent to B. Therefore, we've proved 3 angles and 3 sides. We can now state that triangle XYZ is congruent to triangle ABC. Angle X is called the included angle between the sides XZ and XY. For the next postulate that we're going to use to be true, the angle must be in between the 2 sides. So in this instance, we had copied angle X. We have our 2 rays, and the angle is in between. This drawing has more than one included angle. You could also have angle Y included between XY and ZY. You could also have angle Z included in between YZ and XZ. Make sure you understand the concept of included angle. This brings us to side angle side congruence postulate. Just like we did in the construction, we proved 2 sides and an angle. So if 2 sides and an included angle of one triangle, so it has to be an included angle of one triangle, are congruent to the corresponding 2 sides and an included angle of another triangle, then the 2 angles are congruent. Let's look at our drawing. In this triangle, we have 1 hash mark, then we have an angle, and then we have 2 hash marks for the lengths of the side. If you look at this triangle, PQ is congruent to ST. This angle Q is congruent to angle T, and RQ is congruent to UT. Let's look at another construction. This is another method of constructing the same triangles. In this one, we begin with a side instead of an angle, and we construct XY to be congruent to the length AB. Once again, if you can't remember how to copy a segment, you need to go back to section 1. So we copy AB. With our compass point on X, we draw an arc on this line and make it congruent to AB. Then we copy angle A. So we copy angle A from the original drawing and we place it on our line that we've drawn, XY. And we copy the angle, which will now be angle X. Then we'll construct our third side. We'll construct a second angle, and that angle will be congruent to angle B. So you've already copied angle X, congruent to angle A. Now we're going to create angle Y congruent to angle B. So copy angle B, place it on your drawing, and then you'll draw the line XY as we did in the previous construction we did. You'll now have a triangle that is congruent to the first triangle, but this time we used two angles and one side. Measuring the other three pairs of corresponding parts will show that XZ is congruent to AC, angle Z is congruent to angle C. And therefore we've proved 3 congruent sides, 3 congruent angles, and the 2 triangles will be congruent to each other. So when you have 2 angles that are congruent in a side, we call this the angle side angle congruence postulate, ASA. Please note that XY is the included side between the 2 angles. So we proved these 2 angles, angle X and angle Y, and we also proved the side XY, and that side is in between the 2 angles. It's included in between, just like in SAS, the angle had to be included in between the 2 sides. In ASA, the side has to be included between the 2 angles. It is the angle side angle congruence postulate, ASA. If 2 angles and an included side of one triangle are congruent to the corresponding 2 angles and an included side of another triangle, then the 2 triangles are congruent. In these 2 triangles, you can see we have angle H with 1 arc, congruent to angle D with 1 arc, angle I with 2 arcs, congruent to angle E with 2 arcs, and the included side HI congruent to DE. Example 1A. What additional information is needed to prove that triangle CAB is congruent to triangle CED? So CAB congruent to CED by the given postulate. So we're going to find out what information we need to make SAS possible. Right now we have 2 congruent sides. You can see that. We also have 2 congruent angles because the vertical angles are congruent. What else do we need? Well, we have a side and we have an angle, so we need to declare another side, and that other side will be BC is congruent to DC. Example 2. Given the figure in example 1 and that AB is congruent to ED, can it be proved that triangle CAB is congruent to triangle CED? This is the same picture. So AB could be congruent to angle ED. Can it be proved that these triangles are congruent? Well, one of the things we do know is these 2 angles are congruent, but we have a problem. we have no included information. So no congruent angles are included. We would need at least another angle to prove this, and it would have to be, if we have two sides right here that congruent, we'd have to know that angle A was congruent. We cannot prove triangles using side-side angle. There's a reason for this, and it's not used in geometry, particularly high school geometry. Once two triangles are proved to be congruent, the definition of congruent triangles can be used to state CPC-TC, or the congruent parts of congruent triangles congruent. So once you've proved two triangles congruent, you can begin to take the parts and prove them congruent also. So if we knew that these triangles were congruent, we could now state that BC was congruent to CD, and we could state the angles. In example 3, we have a proof, and we're given a figure. We want to prove that angle M is congruent to angle O. So that means we have to first prove that the two triangles are congruent. So what do we know? They say for the given, they say the figure. So what do we know from the figure? Well, we know that LM is congruent to LO. And that's stated right here. And we have angle MLN congruent to angle OLN. That's our given. Now, LN and LN from both triangles are also going to be congruent. They're the same part, and that's reflexive property of congruent segments. We now have a side and an angle and a side that's congruent to a side angle side of another triangle. So we can state that the two triangles are congruent by SAS. And now, because we know they're congruent, we can now say that angle M is congruent to angle O by using CPC-TC. Lesson 4.3 homework, pages 165 through 167, numbers 1 through 15, 20 through 23, 30, and 34. There is an extra credit problem on the last slide. Here's a very familiar figure, and we're going to go ahead and take a look at what this proof looks like. So number 18 says given the figure, so let's pick out what we know about the figure. We know first that we have some parallel lines. So let's state that AB is parallel to ED. And we also know that we have AC congruent to DC. We also have two angles here. It says the vertical angle theorem. We can name these angles, and we'd say angle BCA is congruent to angle ECD. We've already proved a side and an angle, and remember the angles have to be included, so that means we need to prove these two sides right here, and oh, I'm sorry, I guess the theorem's not going to prove it the way I usually prove it. We're going to do angle, 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 side angle, sorry. This says alternate interior angle theorem, so we're going to prove now that angle A is congruent to angle D by using that theorem. What I just showed you is that there's more than one way to prove a theorem. Triangle CAB is congruent to triangle CDE, and that will be our ASA postulate. And you can write it just like that. You don't even have to put the congruent symbol. Number 19 is similar, same drawing, but this time they want us to use a little bit different idea. So it says here that C is the midpoint of AD and BE. So we can see that here. C is the midpoint. What that's going to do is produce some congruent links, and we'll have AC is congruent to DC, and BC will be congruent to EC. Angle BCA is congruent to angle ECD. So BCA is congruent to ECD, and let's get our markings right here in our drawing, and we can prove that because vertical angles are congruent. Now, triangle CAB is congruent to triangle CDE. What have we proved? Side, angle, side. Now we can take a piece of this, and we need to prove that these are parallel lines, that AB is parallel to ED. The way we can do this is by using another set of angles, and those angles, and you actually have two options here, but I'll pick this one. I'm going to pick angle B and angle E. So angle B is congruent to angle E, and it says CPCTC, but the reason we know they're congruent is because we've already proved that these triangles are congruent. We could also have named angle A and angle D. We can now prove that AB is parallel to ED because of alternate interior angles. This angle B and E are inside of parallel lines, and here and BE is your transversal. If the described triangles can be proved congruent using SAS or ASA, write a valid congruent statement and name the postulate that justifies it. If not, write neither. So, number 20, it says AB equals EF, BC equals DE, and the measure of angle B equals the measure of angle E. So we have two triangles here, and these triangles we have to find out if we can say that they're congruent. So let me just go ahead and label. They don't give you triangles for the homework. I put the triangles in there because it gives me a visual. So AB equals EF. So right now I can set this up for them to be congruent. BC would be congruent to DE. And the measure of angle B would be congruent to the measure of angle E. It says write a statement, and we can now say that triangle ABC is congruent to triangle. And if you look at ABC, it's 1 hash mark, angle, 2 hash marks. So 1 hash mark, angle, 2 hash marks. So it'd be triangle FED. And how would they be congruent? By SAS. Side, angle, side. Your extra credit problem. Write a triangle congruence statement and name the postulate that justifies it. Hope this helps. Contact me if you need any assistance, and we'll see you soon.